Hey guys, welcome. So we'll be presenting article 408, and this article will focus on switchboards, switchgear, and panel board. All right. So this presentation was brought to you by the Visionary Society of Engineers. Right. So we are here to offer help for persons who are operating within the electrical field. And of course, we provide networking opportunity for persons who are interested in learning more and to foster their talent within this discipline, right? So before we go ahead, we'd like persons who are watching this video to subscribe, like, and as well share for persons who they know operating within the same capacity. All right. So the article 408, we covered switchboard, switchgears, panel board. And for this article, it does not exceed 1,000 volts. Furthermore, circuit breaker overcurrent device and switchboard, switchgears, panel board, and their enclosure shall comply with this article. Now, when we talk about a switchboard, we may think of a standard switchgear, right? Rather, a switchboard as in having multiple switches within an enclosure, right? Or a panel board of such having breakers assembled all together on a bus, right? And then we may look at a switchgear as in a switch itself that stands independently, that is used for disconnecting the service. Now, in terms of switchboard or switchgears and panel boards, we have features such as the bus bar, the terminals, wiring space, and the spacing arrangement of where the conductors will land, and the terminals, for the switchgears. And then we will look at the identification as it relates to how we name panels, how we assign labels. So each switch gears within a switchboard are independently a switchgear by itself. Then we can look at the arrangement of the switches and the switchgear in terms of location. Now, for location, we must have the conductor and the bus bar in a way that it is protected from physical damage and ensure that they are properly supported and firmly in place. Service switchboard or switchgear. Normally, you want to have barriers to ensure that these bus or terminals that are ungrounded is so arranged in a way so to avoid inadvertent contact by persons or maintenance, equipment, servicing, or terminating. Right? So whenever any person are doing any work, insulation that is provided between the gears or the terminals does not allow metal to metal contact between, like a phase, right? So you have multiple phases and each are allowed to touch each other. Now the insulations that is provided provide separation. So even so we are doing any servicing on a live switchgear, there can't be any contacts taking place, as the terminals are separated by insulation. Next thing we're going to look at is the vertical section. As you can see, within every section, you may have ground, you have neutral, and then you have the ungrounded terminals. Right? So the section is supposed to be intended for the allocations of those wires that is going to terminate it within it. Anything separate from the control wiring should not be allowed, right? So within the space for terminating the designated grounded or the ungrounded conductors should only exist and should not make room for any other conductor, right? Next thing we're going to look at is overheating and inductive effect. Now, overheating is commonly when it comes to reactive loads, right? Reactive loads commonly create the presence of noise within a circuit, right? Reactive load are loads that are created by inductance or EM fields or magnetic fields, right? So the arrangement of the bus bar shall be as such to avoid heating on the conductor. All right, and this is due, as we said, to the inductive effect caused by an EMI signal introduced by changing magnetic field. Right, so most reactive loads have an inductive effect within the supply or the electrical signal, right? So the effect of the noise commonly resulted in heating of the conductor terminal, and so proper termination is required. So the next thing you gotta do to avoid such effect is having the adequate distance separating the conductor terminal and the bus bar. All right. The next thing that is deemed appropriate is shielding. Right. So you can have shielding between the terminals, right, and also shielding along the bus, right? But it's highly unlikely for the bus bar to be shielded. However, in the case of having terminals in its close proximity, then we can utilize shielding for that purpose to protect against the effect of overheating, right? Next thing we're going to look at is grounding, right? So the main purpose of grounding is to help to normalize the voltage, and it also serves as to reduce any effects of the overheating due to the noise that is induced into the circuits. All right, and the next thing we can do in a way to avoid such problem is monitoring for the proper frequency. All right, so if you study frequency, it is a change in the voltage in respect to the time, right? So when you have a frequency that is way out of range, it may cause a spike in terms of the EM field, and the effect of this introduction of noise within your circuit can result in the same inductive effect on the terminals between conductor A and conductor B or conductor C. All right, so proper frequency should help us to avoid any overheating on the conductor. Next thing we're going to look at is the service equipment. So all sections of switchboard switchgear shall be bonded with a main bonded jumper size in accordance to 250/28. All right. Next thing we're going to look at is the switchgear panel board, and that must be connected to the service ground on the supply side to the switchboard or the panel board frame. All right. So that is what we meant when we use a switch as a service equipment, right? So we must establish the main bonding jumper, right? And all sections of the switchboard or the switchgear shall be bonded together using the equipment bonding jumper or the equipment bonding conductor, right? And this covers under 250, 122, and 250.66. All right. So these equipments, when used as a service, should establish the main or supply bonding jumper, right? And the sections or all sections of the switchboard, we should establish follow Article 250, 122, and 256. All right. So that is the rules for using equipment as service. Now, terminals and bus bar arrangement. Now, in the case that we're using equipment, right, or say for switch gear rather, in the bus bar and the terminal arrangement, they should be in such a way that they don't cross each other. So looking at the terminals, right, or the bus bar, right, in this diagram here, we are not able to see a bus bar being exposed, but yet we have the terminals. So if you notice how they're arranged, they're clearly not crossing each other as much as close as they may be. They're in a designated position. So you have the red or the black, the red, or the black, blue, and the red, all in their designated locations, and that follows by the neutral. So the terminal for the field wiring, including the grounded conductor, shall be so located that it is, or rather does not reach across any ungrounded conductor. Right? So the next thing we're going to look at is the bus bar arrangement. For the AC phase arrangement, as we're looking at here, they're typically labeled from left to right, top to bottom, or front to back. Right? So we want to ensure that we have the labeling in sequence, as in phase 1, phase 2, and phase 3. Or starting from phase A, B, and C. All right? And that should maintain consistently throughout. From left to right, top to bottom, or front to back. So the next one we may look at is DC phase arrangement. Right? The only difference though with DC that they can rearrange in any order. Right? So direct current bus arrangement is okay to be arranged in any particular order. Now, when it comes to switchboard, switchgear, panel board identification, right? Caution signs or label provided in accordance with 408.3. Those identifying the ILX, right? And the ungrounded AC system, the high impedance ground, the neutral AC system, the ungrounded DC system, and resistive grounded DC system. All right. So we must properly identify different systems that is installed so as maintenance personnel can understand what is required in maintaining or servicing those equipment. Right? So whenever the switchgear is arranged with yes, designed in a certain way, so we have to make sure that we have proper understanding in terms of the kind of system that we're working on. Right? The next we're going to look at is the bending space. Right? So for switch gears, panel board, we should have spacing available for the wires to come within. So for example, we're going to terminate cables within a breaker panel, or we're going to bring in the cable into the terminals or the lugs. All right? We must have appropriate spacing for the cable. Therefore, we can use the right spatial arrangement by determining the size conductor that is supposed to come within the panel, the switchgear, the switchboard, or the panel board. So Article 312.6 can help us determine the size cable, not the size cable rather, but the size, rather the spatial arrangement between the terminals, right, for the top of the terminals to the back of the enclosure. So that is important as we determine the appropriate bending space required for conductor coming in within the panel board or the switchboard. Right? So minimum required bending space must be determined. The next thing we're going to look at is the field wiring. All right. So the field wiring is the wiring that goes out from your panels and it moves out to your load. Right. So when it comes to field wiring, you should have the circuitry directory or the circuit identification. Field wiring may also include individual circuits and must be legibly identified as clear and evident for specific use. Right? So when it comes also to such wiring, each circuit must be distinguished from all other. Any spare made available should be identified, right, on a panel board, or whether it's coming from the panel board and going out within the field. The panel identification must be located on the face or inside of the panel board, right? So a list of identification determining breaker must be labeled from on a panel board and must be located on the inside or the face of the panel board. And in some case where there's a switch gear is concerned, or from a switchboard, we have different switch gears. We must have proper labeling, right? For those switches or switch gears that is heading out to the field, right? So the field wiring also is a part of the identification for the source of supply. Right, so all switchboard, switchgear, panel board supplied by a feeder in other than one or two dwelling unit shall be marked to designate where the power is coming from. The feeder shall be easily traced back to its originating switchboard, switchgeared panel board. Such field wiring is also determined to be identified, right? Such to provide accurate identification of circuits to promote efficient blackout or tagout within the process.